Hey everyone, welcome to part 10 of manual software testing interview questions, and in this video we are going to cover another very important 10 interview questions which are as follows. So the first question that we are going to discuss today is what is the difference between incident and defect, which we have already covered in previous video, but briefly we'll touch base on the difference again in this particular part. Now the next thing we'll cover on the similar line is what is the difference between error, bug, defect and failure. And that is very important question because you might be asked about the differences between error, bug, defect and failure, and you should actually, these are the basics, so you should be across it. Now the third question that we are going to cover, or 93rd question as part of this whole series, is what is the difference, what is defect severity and priority, how do you assign defect severity and priority, who assigns defect severity and priority, right? Then what is defect report, what is the defect detection percentage, what is defect life cycle, very important question, what is configuration management, and what is version control. So let's quickly go ahead and start these questions one by one. So the first question, what is the difference between incident and defect? So the brief and shortest answer for this is that incident is a defect or bug only when the root cause of that incident is some problem with the item being tested, right? So whatever you are testing, whatever application you are testing, software you are testing, if the problem is within that particular application, whether it is because of the mismatch of the requirement or the gap in the requirement, or there is some error when you are launching the application, when you are putting some information, submitting the information, any of the functionality. So for example, if we take the e-commerce website, right? So you are trying to log in and then trying to order some items from the website. When you go to the payment or checkout, you are getting payment failure or error, abrupt error. So if that is the scenario, that is basically what the defect is. Okay, so a defect can also be a gap or mismatch in the requirement. It's not only that only the software that you are testing, there could be a defect. A defect could be in the requirement. The requirement might not be captured properly, or there will be incorrect information in the requirement, which can be flushed out when the team works together and more clarity is available from the tech stakeholder, from the business stakeholder, right? Now incident is any sort of incident or mismatch from the actual with the expected, which could be, there could be many reasons. There could be reason because the test data that is being used is not correct. Now if the test data that is being used to test something is not correct, that is not a defect because it's a issue with the test data, right? It's nothing to do with the actual implementation of the software. The software is fine. The steps or the data that the tester or the person is following itself is not correct, right? Or maybe the person is not testing the application in the right test environment. So any of this can lead to an incident, right? And that incident will get converted to a defect only if the root cause is the actual issue with the software or with any of the requirement or design. Okay, so that's the basic difference between incident and defect. Okay, so next question, 92nd question of the series is what is the difference between error, bug, defect and failure, right? So very minor difference. So usually you will see that defect and bug are used interchangeably. Okay, so some projects you will see that are using terminology as bug, some projects use defect. But if we talk about the basic difference between defect and bug, so defect is any deviation because of the requirement issues. Okay, that's what the definition says. And bug is any deviation from actual to expected because of the coding issues, right? So this is very fine difference, but because in the projects people do not bother too much about whether you are using a terminology bug or defect, so you will end up using interchangeably, right? So there is no sort of categorization, separate categorization in the project whether that you have a defect as well as bug, right? So mostly there will be a subcategory that you can choose to categorize what is the root cause of that particular defect, right? So that is where the subcategory categorization becomes helpful, and defect and bug are mostly in the real-time scenarios. It will be used interchangeably and will refer to the same thing, which is any deviation or error because of the requirement or the coding issues. But the fine difference is defect is a deviation because of the requirement issues, bug is the deviation or error because of the coding issues. When we say error, now error is any error in requirement, test data, test, coding, any error, human error that has been made and that can be rectified. So that is basically what the error is. Now what is failure? An error that has been made either into the requirement, into the design, into the coding, right? So all these software applications are built by humans, and humans can make error. Everyone is human being, so you can make an error at any time. So any error which leads to a failure is the failure, right? So basically, for example, in e-commerce application, I'm trying to log in, but I'm not able to log in because of the coding error that was made by the developer in the login module. Okay. Or when the developer was trying to fix something, then this error could be also because the incorrect requirements were documented from the business analyst, right? Or the error could be, or failure could be in the production because that particular scenario was somehow missed out into the testing phase. So a failure is basically any failure in the software that is led by any of the errors. So this is the basic difference between error, bug, defect and failure. Now moving on to the next question, which is 93rd question. What is defect severity and priority? Okay, so very important question. Most of the time in most of the software testing interviews, wherever you'll go, you'll definitely be asked this particular question. So defect severity means how badly the defect has impacted or affected the functionality of the application. Okay, and defect priority defines the order in which developers will fix the defect. Okay, so defect priority is mostly driven by business and severity is mostly driven by or defined by the testers or the person who is analyzing the impact of that particular defect on the functionality, right? Now say for example, I am testing an application, e-commerce application. Okay, now if I log in as a customer and I try to add the items into the cart, right, and the items are not getting added into the cart at all, right? Now this particular defect, because the items are not getting added to the cart itself, I cannot go ahead and proceed with any further scenarios. For example, removing the item to the cart, checking out, right, making more purchases, doing the payment, all of that is not possible because cart itself is not getting populated. Items are not getting added to the cart. So this defect is very severe because it is impacting a core functionality that is blocking other key functionalities of the application and blocking the tester from test other critical functionalities. So obviously this particular defect severity will be really high or highest or even critical, right? So now why does this severity, or how does this severity get defined basically? So now this cart example, right? So this is highly severe. Now low severe, if I say low severity, so any defect which is actually impacting the application functionality, but there is a workaround, then that defect is defined as low severity defect. For example, if a customer is trying to register, right, so with the particular data, or say for example with the particular account or a Google account, they are not able to register, but with all other social media accounts they are able to register, and with email they are able to register. So this particular Gmail or Google account, there is a defect, right? The person is not able to register using Google account. So this is also a defect, severity, right? Because it's impacting the functionality of the application. But this severity is low because all other pieces or registration pieces are working fine. So this is not blocking the overall testing or overall flow of the particular application. And similar is true in the production as well. If something critical fails, or something, for example, add items to the cart, right, that fails in production, that is basically blocking every person who is accessing the e-commerce website to proceed and put the order. But if there is a registration functionality specific to the Google that is not working, still there will be less percentage of user who are, or little percentage of user who are using Google account. Only those those many people or those percentage of people will be impacted, right? So that's what the defect severity is. So severity is any impact on the functionality, and priority is in what order those particular defects need to be fixed, and this priority is defined by the business. Why? Because even though there is a high severity defect, okay, now Google registration is a high severity, can be high severity as well, right? I mean, it's complete one flow is not working, okay, but business can decide that, yeah, even though this is high priority, but we still have time to release it in production, so we will fix it in, or product owner can say, yeah, we can fix it in next sprint, or in another 2 sprints we can go ahead and fix it. There are other important stories and defects that need to be tackled here, right, or in this particular sprint. So priority is mostly decided by the business or product owner, anyone who is from the business. They decide in what order the defects will be fixed by the development team. So that is basically what is defect severity and priority. Now moving on to the 94th question. How do you assign defect severity and priority? Okay, so how a tester, as a tester, you will go ahead and analyze that this particular defect needs to have the high severity, medium or low severity, right? So higher the impact of a defect has on the development or operation or a component, the higher the severity, okay? And then the priority is defined based on the higher the impact of the bug or defect on the business, on the revenue, on the customer satisfaction, the higher the priority of that particular defect will be. Now I'll take an example here, okay? So if I talk about a high severity bug, right? So same example, e-commerce website. Now e-commerce website add items to cart is not working. That's high severity because the impact on the development operation testing is too high, right? None testers are able to proceed further. So that is high severity. Now if this particular defect needs to be, basically if business comes through and says, analyzes this particular defect, and there is a defect triage meeting that happens wherein all the analysis will happen, what are high priority defects that have been raised, what are medium and low, and based on this then business will say, okay, there are so many testers who are blocked because of this particular defect, they are not able to proceed further. The priority of this particular defect add to cart will also be high. That's how it is basically defined. So severity is the impact on the work, on the system, on the software, right? And priority is what business thinks that in what order this particular needs to be fixed, right? Now because add to cart is blocking so many other user stories and other work, so that will be high priority to be fixed quickly, right? Now high priority, okay, or high severity but low priority, okay? So for example, Google, okay, so Google login or Google registration is failing. It's high priority, but in the testing life cycle or in the STLC, when the testing is happening, there are so many other work that testers still have to complete, right? So this particular defect, which is registration using Google account, can still wait for another week or so to fix. In that case, the severity or priority of that particular defect will be reduced by business, and they'll say, okay, you can fix it in. Now low severity but high priority example. So for example, you are a reputed organization, you are Google, okay, and on your Google website, okay, the home page, there is a spelling mistake, right? Now the spelling mistake on a website is not causing any harm or any damage or any functional damage basically, right? So functionality, everything is working absolutely fine, but being such a reputed organization, a spelling mistake on home page of the main website is not acceptable, right? It's not a good sort of image with so many audiences and customers that you have overall. So this is low severity, but business will say, no, this needs to be fixed immediately because we by mistake, or we cannot have this particular severity defect, or even though it is low severity, but we cannot have a spelling mistake on our key website, right? So this is example of low severity and high priority. So business will say this needs to be fixed immediately before we move on further with other scenarios and development work. So this is basically how you assign severity and priority. Priority is mostly done in the defect triage meeting, wherein business decides in what order the defects will be fixed by the development team and when they will be fixed, right? Okay, so let's move on to the 95th question. Who assigns defect severity and priority? Now, very simple, similar lines. So severity is categorized by the testers, whosoever is testing, because you as a tester know what is the impact of this particular defect in the functionality, on the functionality. So if I say, yeah, add to cart, right? Add to cart is blocking so many other modules. I'm not able to progress with the testing at all, right? So I'll say, yeah, this is highest severity, right? This is highest severity. And the level of severity and priority, it depends on what is being used by the project. So there are some places you will see 4 levels of severity or 3 levels of severity: highest, high, medium, low. 4 levels is highest, high, medium, low. Similarly to the priority, right? So there will be different levels of priority as well. So severity is categorized by the testers and priority is decided by business stakeholders, product owners, right? So anyone coming from business, they will decide the priority of the defect. And when is the priority decided? So as a tester, you raise the severity, or you raise the defect, you assign the severity. Okay. And see, most of the time in real scenario, you will also see the priority column or priority section in the Jira ticket as well. Okay. So you as a tester might be populating both fields. Okay. And then priority might be changed later when defect triage meeting happens. And when we say defect triage, the product owner, the team lead, test lead, and other development stakeholders, development members come together and they see the list of defects that have been opened or that have been created on a daily basis, and then going through one by one, analyzing, and then assigning the priority to those defects. That's what defect triage meeting is. So that's about the question, who assigns defect severity and priority to defect, right? Now 96th question, what is defect report? Okay, so defect report is a document that has concise detail about the defects. Okay, now defect report, as the name report itself is there, so it's a report for defects. Okay, and that report contains information about the defects in a particular cycle, in a particular phase, in a project. What all defects were identified? First thing, how many defects were identified? What steps, what action steps make the defect show up, right? And then what are the expected results instead of the application showing error while taking particular step-by-step actions. So if I talk about a real, example of what the report will look like. So basically in Jira, you have these plugins, or in Jira by default, you have the defect management capability already. So you can open the defect template and you specify what defect has been identified, what steps you have taken to identify that steps as a tester, right? And what was the expected result that you were expecting, but actually you got something else, some other. So when you define all these details in that particular tool, in the template, and submit it, right, then that is what a defect reported. It's basically a short documentation, and tools provide you all of that capability. So Jira has that capability. There are many other test management tools that have that capability or defect management capability within itself, or you can achieve it using some of the plugins. So then that particular defect is raised, it will create a unique identifier, and that ID is used to track that particular defect further. Okay, but key information is the summary of the defect, the actions that you took, steps to reproduce that defect, and then what you were expecting, what is the actual result, any screenshot, any logs that you need to attach that are helpful for root cause analysis to the developers. You attach those to the defect report as well. So that's what the defect report is. Now here you might get confused that it's a document, it's a Word document. It's nothing like that. There are tools there. Okay, but if there are no tools, then if you are a very small project, you might be maintaining all of that in the Excel sheet. So you can go ahead and maintain all of these steps and details into the Excel sheet or the Word document. But highly unlikely, there are so many free tools available that you can, most of the projects will be using, the defect management. For example, Bugzilla is there, right? So there are many free tools available. TestLink is there for test management and defect management. So you can use any of those. Okay. So that's the defect report. Now the next question, which is what is defect detection percentage, DDP? So defect detection percentage is a metric wherein it compares field defects. Okay, field defects, when we say field defects, it's the defects that are found in production. Okay, when the software has been released in the production, after releasing in production, what defects have been identified by the end user and the customer. Okay, so it's a percentage that compares defects that are identified with the field defects that are identified in the field with the testing defects, with the defects that are found by the testing team, right? And it is very important metric to find effectiveness of the test process, right? Why? Because say for example, you have found the 100 defects. Okay, you have found 100 defects during testing, but then you found 200 defects in prod, right? Obviously your effectiveness or testing team's effectiveness is very low because there are 200 defects that are identified outside of the testing team, right? So there is a specific formula for DDP, which is defects that are found by the testers. Say for example, 100 defects have been identified by the testers divided by defects found by testers plus defect found by the in the field. Okay, so if 100 defects are found by the testers, 100 divided by 100 plus 200, if 200 defects were found in the production or in the field, so 200 plus 100, so 100 divided by 300, which is basically 1 by 3. So that is very bad defect detection percentage. So this is helpful to analyze and see the effectiveness of testing team and basically to see that are we actually preventing and finding the defects during the testing phase and prior to testing phase itself or not, or are we basically or there is a lot of defect leakage to the production from the testing phase. Okay, so that's what the defect detection percentage is all about. Now moving on to the 98th question, what is defect life cycle? Right, now whenever there will be a defect, there will be a process to follow it, right? To basically make sure that it follows the right steps and phases so that it is addressed properly in the project, right? So defect life cycle is nothing but a cycle of process of defect from which it goes through, covering the different states in its entire life, right? So when the defect is open, it is new, then it's moved to the developer to be fixed. That's a different state. Then they fix it, assign it to tester, then tester tests it. If everything was working as expected, tester will then close it, right? So this is brief life cycle or defect life cycle, or a process that needs to be defined in any project for managing the defect, right? So defect life cycle is nothing but a cycle or a process that a particular defect or the defects in a particular project are going to follow so that there is a systematic way to manage those defects, right? Now imagine if you have a defect, okay, and you don't have the process to follow those. So if a defect has been raised and somebody just stood up and dropped an email that this is a defect, right? So will you be, is it effective to track that particular defect over the email, right? Then that email is forwarded to the developer to be fixed, then he'll forward, or if say for example they are not able to follow it up, it got missed. That is a big nightmare. And if say for example hundreds of defects are being raised in the email using the email chain, it is very, very bad practice, right? So that is where defect management comes in picture, and defect life cycle helps. There is a specific tool, or in the tool itself, in say for example Jira you are using, within there you can basically filter out all the defects, and then there is a specific cycle or process that is being defined to manage those defects, and who is working on those defects. They can be assigned, they can be reassigned. What is the status of those defects? There will be filters that you can use to filter out, and also see what all defects have been raised, how many defects are there, in which state they are, whether they have been addressed or not. So that is what all is being provided when you follow the defect life cycle, right? So defect life cycle is nothing but a process or a cycle which is followed by the defects in a particular project, right? And defect life cycle will start as soon as the new defect is found by the tester, and it is also known as bug life cycle, right? So defect and bug are used interchangeably. There is a minor defect, but they are used interchangeably. So It is also known as bug lifecycle. Now moving on to the 99th question, what is configuration management? Okay, very important question. So configuration management is a discipline. It's an umbrella term, you can say. It's a discipline for systematically controlling the changes in the system, software, supporting documents, and there are many other things, right? So it's not just the system or software or the documents. There are many other things that can be controlled, systematically controlled during the software development life cycle. Okay. Now when we say system, so there are system configurations, right? When we say software, you need to maintain the different versioning of the software, right? So you can't just keep working on a plain text file and deliver or release the whole software. Supporting documents, test case, test plan, there needs to be a proper version controlling, right? So for all of that, you use the tools which provide you that configuration management capability. So configuration management is not a single tool or something. It's a discipline overall to effectively control and manage, systematically control and manage the changes in the system, in the software, in the supporting documents, etc. Right? For example, if you're writing a test plan, right? So most of the time you manually go ahead and change it to the version draft and then version 0.1, version 0.2. But if you maintain the same thing in Confluence from Atlassian does it automatically, right? The version control, you can revert back to the old version. So that is all possible out of the tool itself. So version control is one aspect of configuration management. Okay. So configuration management, if somebody asks, it's an umbrella term. It's a discipline overall to manage the changes in system, software, documents, anything. Okay. And there are many configuration management tools, for example, Ansible, Chef, right? And then you have Git, Bitbucket. Okay. So all of that, these tools, so Git, Bitbucket are mostly for the source control or version control, software for the software code. Then you have Jira and Confluence basically for managing your documentation, version controlling those, and then Chef and Ansible for mostly DevOps, right? So that's all basically around, it's an umbrella and which contains a lots and lots of tools. So we don't want to go into too much detail there, right? That should be good enough for you as a tester to explain your interviewer. Okay. So that's the 99th question. Now the 100th question. So part 10, 100th question. So with this, we have completed basically 100 question as part of this whole series. So what is version control? Okay. Now version control is one of the parts of configuration management. As I said, configuration management is a discipline and version control is one part of it. It's a practice of tracking and managing changes in software code. Now when we say version control, it's not very specific. It's not just specific to the code, but because version control is mostly or very heavily used with the software developers, so that is why Git, Bitbucket, GitHub, all of this are version control systems, and they are used to manage and track changes into the software code. And version control systems are software tools that help software teams to manage changes to source code over time, and version control systems are also known as source control systems. So Git, Bitbucket, right? CVS, there were some older ones as well, but Git and Bitbucket are the very popular ones that are very widely used nowadays for the version control of the source code. Now if I say version control is also available in Confluence. Version control is also available in many other tools. In test management tools it is available, right? So it's a capability as well. It's not just for the code, it's for the document. So any tool or system or practice that you utilize to control the versioning or the changes in the version is a version control. You can do version control manually as well. When I create a new document, when I open a new Word document, right, I just wrote one line today, okay, and I save it as version today's date. All right, and then I opened it tomorrow, I change something, and then I save it as a new version, okay, with tomorrow's date. So I'm manually maintaining these versions. So you can do version control because you can do it manually, but manually it becomes a really tedious process, right? So that is why these tools are available to help you in all of that version controlling journey. Okay, so it's a practice for tracking and managing changes in software code, in your document, comment, anything, right? So that's all for this particular video, part 10. And with this video, we have covered 100 manual testing interview questions. I have prepared few more testing interview questions, so I'll be producing more videos on this particular series. Along with that, I have also thought about some of the other interview questions, for example, around the behavioral software testing interview questions. So hit a comment or just comment in this particular video if you want me to release a behavioral software testing interview question series as well once I finish this particular. So based on the comments, I'll start preparing on the other series. So that's all for this video. I hope it was helpful. Thank you very much for watching.